Hello viewers, in today's class we are going to discuss one important and conceptual problem from integrals, right? And here we have to solve this integral from 0 to 31 pi over 3, and the integrand is mod of sine x, right? So let us start, and here let us first call this integral as I, right? So in order to solve this integral, we have to make use of certain important results from definite integrals as well as from trigonometric functions, right? So we'll solve, or we'll see the results when we move further, right? So here, see, the limits of integration are from 0 to 31 pi over 3, right? So what we will do here, the first step is to split this integral as a sum of two integrals, right? So what we will do, we'll write here I1 plus I2, and we'll see what are the values of I1 and I2, right? See, the lower limit is 0 and the upper limit is 31 pi over 3. So now 31 pi over 3 can be written as 10 pi plus pi over 3, right? So we can break 31 pi over 3 as 10 pi plus pi by 3, right? So now see, I1 can be written as 0 to 10 pi, and we have mod of sine x here, and then I2 can be written as 10 pi to 10 pi plus pi over 3, and here we have mod of sine x, right? So the important thing is that 31 pi over 3 is written as a sum of two numbers here, two real numbers, 10 pi plus pi by 3. So we break this integral as a sum of two integrals, and the breaking point is 10 pi, right? So the first integral goes from 0 to 10 pi, and the other integral goes from 10 pi to 10 pi plus pi by 3, which is obviously equal to 31 pi over 3, right? So here we have used the property of definite integrals, that is, if we have a to b f of x dx, and if c is a point between a and b, then we can write it as a to c f of x dx plus c to b f of x dx, right? So when c lies between a and b. So now we have these two integrals. So now our next step is to evaluate these two integrals separately, right? So for the simplicity and for better understanding, we'll treat these two integrals separately, right? So let us first take this one. So here we have I1. So I1 is from 1 to 10 pi, and here we have mod of sine x and dx, right? Okay, now here what we will do, we'll make use of the concept of periodicity of trigonometric functions, right? See, we know that the period of sine x is 2 pi, right? So this fact is well known. So period of sine x is 2 pi, and the period of mod of sine x is pi, right? So this is the concept which will be used to evaluate this integral, right? So here we'll mention one property of definite integrals which is used to evaluate this integral. See, we know that if we have an integral of this type 0 to nt f of x dx, right? So if we have an integral of this form where n is some number here and t is the period, right? So t is the period. So if we compare this integral with this one, see, here we have 10 pi, right? So the value of n is 10 here, right? If we compare this integral with this one, and pi is the period of mod of sine x, right? So the value of t is pi, right? So when we have an integral of this type, then we can write this integral as n times 0 to t of f of x dx, right? So now applying this property to this integral, see the value of n is 10, so we can write 10 times integral 0 to pi, right? So 0 to t is the period, and f of x dx implies mod of sine x and dx, right? So now with the help of this property, we have reduced this integral to this one. Now see, from trigonometry we know that in the first two quadrants sine is positive, right? So the sine function is positive in the first and second quadrant. So when we go from 0 to pi, that is from 0 to pi, then mod of sine x must be equal to sine x, right? Because 0 to pi lies between the first and the second quadrant, right? So here we can write 10 times 0 to pi, and for mod sine x we can write simply sine x dx, right? So from the definition of mod function, see, mod function says that mod of x is positive x whenever x is greater than or equal to 0, and minus x whenever x is less than 0. So mod of sine x is positive sine x because sine x is greater than or equal to 0 in the interval 0 to pi, right? So now we have 0 to pi sine x, and this is an easy integral. The integral of sine x is minus cosine x, and we have the limits 0 to pi, and we have 10. Now we can take this negative sign outside, so we have now minus 10 cos x and 0 to pi, and we have minus 10. We'll substitute the limits and we'll take the difference. So we have cos of pi minus cos of 0. So we have minus 10 here. Cos of pi is minus 1. Cos of 0 is 1. So we have minus 1. So this is minus 10 times minus 2. That is plus 20. Right? So the value of this integral I1 is 20. Right? Now let us consider the second integral. Now to evaluate this integral I2, we have 10 pi to 10 pi plus pi by 3 and mod of sine x, right? Okay, now here again we have to make use of one important property of definite integrals, right? And the property, it goes like this. See, if we have a plus nt, and here we have b plus nt, and here we have f of x dx, right? So here we have a and b are two numbers, and t is the period of this function f of x, right? So if we have to integrate a function, a periodic function f of x from a plus nt to b plus nt, then we can simply write this integral as a to b f of x dx, right? Okay, so now we have to apply this property to evaluate this integral. So what we will do, we'll first try to express this integral like this, right? So for this, what we will do, see, we can write the limits like 0 plus 10 pi, right? So 10 pi can be written as 0 plus 10 pi, and the upper limit can be written as, we can shuffle these two numbers. So here we have pi by 3, and here we have 10 pi, right? And here we have mod of sine x dx, right? Okay, so now without changing this integral, we have expressed I2 as this. So now if we compare these two integrals, then see, this is a, right? So a is 0, here pi by 3 is b, right? And 10 is n, this n, and here also this 10 is n, and pi is the period of mod of sine x, right? So t is pi, right? Okay, so this is perfect, and now we can write this integral as a to b, right? So here a is 0 and b is pi by 3. So here we have 0, here we have pi by 3, and we have mod of sine x, right? And once again, we know from trigonometry, see, this is 0 and this is pi by 3, and pi by 3 is 60 degrees, so it is like this. Here we have pi by 3, so it implies that we are in the first quadrant, right? So first quadrant, and in the first quadrant sine is positive, right? So now we can safely remove the mod sign here. So we have 0 to pi by 3, and here we have simply sine x, right? So here we can write positive sine x, because mod of sine x is the positive sine x, because sine x is greater than or equal to 0 when x belongs to 0 to pi by 3, right? Okay, now the integral of sine x is minus cos x, and we have 0 to pi by 3. The limits are 0 to pi by 3. Now we can take this negative sign outside, and we can take the substitute the limits here. So we have cos pi by 3 minus cos of 0, and here cos pi by 3 is 60 degrees, so this is half and this is 1, right? Cos 0 is 1. So we have minus here, half minus 1 is minus half, so this is positive half, right? So the value of this integral is half, right? And what we have to find? We have to find the value of this integral I, which is the sum of these two integrals. So this is 20 plus half, so this is 40 plus 1 over 2, that is 41 over 2, right? So viewers, this is how by making all these results we can find out the value of this integral.